Good morning, dear students. A warm welcome to all of you for our today's digital revision session for the subject Science and Technology Section A. Yesterday, we have revised chapter number 12, Study of Sound from Section A. So, today we are going to revise chapter number 13, Carbon, an Important Element, and the topic will be revision of all the concepts which we have studied in this chapter. So, let us begin. Carbon, an important element. During explanation time, I had told you why this name is given to the chapter or why carbon is called as an important element when so many elements exist around you. If you take examples of different substances like foodstuffs, clothes, medicines, fuels, wooden objects, everywhere in all these substances you will find that carbon is the common and important constituent, and hence carbon is categorized as an important element. Now let us move towards the chemistry of carbon. The symbol of carbon is capital C, atomic number 6, atomic mass 12, electronic configuration 6 electrons, so 2 in the first shell, 4 in the second shell. Valency is 4. Ahead in this chapter we have seen how carbon, instead of going for a give and take relationship of electrons, it rather decides to share the electrons, thus forming a covalent bond, and it is a non-metallic element. Now, compounds which are obtained directly or indirectly from plants and animals, they are called as organic compounds, and those which are obtained from minerals, they are called as inorganic compounds. And all the organic compounds which you see around you, they contain carbon, and also carbon is the main element in cellular DNA and RNA that transfer the hereditary characteristics from one generation to the next generation. In chapter number 16 of biology, we are going to study about DNA and RNA and about the transfer of these characteristics in details. Now, such an important element carbon, let us see where it occurs. Now, carbon occurs in both the states, that is the free state as well as the compound state. So, free state it is found only as diamond and graphite, and in the compound state or combined state in so many forms. It is available as carbon dioxide, then in the form of carbonates such as calcium carbonate, marble, in the form of fossil fuels, in coal, petroleum, in the form of carbonaceous nutrients, carbohydrates, proteins, and also you will find carbon in natural fibers like cotton, wool, silk. So everywhere you can see carbon is present as an important constituent, and hence it is an important element. Now we will move towards the study of properties for carbon. Carbon is that non-metal which exhibits allotropy. What do you mean by the allotropic nature of carbon? What is allotropy? Some elements, they occur in nature in more than one forms, and the main characteristic, the unique, you can say, characteristic of allotropy is that the chemical properties of these different forms are same, but physical properties differ, and this property of elements is called allotropy. So this is definition for allotropy. Now carbon also exhibits this property. The various allotropes of carbon are the crystalline forms and the non-crystalline or the amorphous forms. Now one by one we are going to study the properties of crystalline forms. Crystal, this word itself tells you that there is some definite arrangement of atoms, and there is an arrangement which is made in such a way that a proper crystal is formed. So the first property has a regular and definite arrangement of atoms, high melting points and boiling points, has a definite geometrical shape, sharp edges and plane surfaces. These are the properties of crystalline forms. If you go ahead for the non-crystalline forms, they have not given the properties, but exactly opposite will be the properties of non-crystalline forms. For the first you will write they do not have a regular and definite arrangement of atoms, melting points and boiling points are low, and they lack definite geometrical shape, sharp edges and plane surfaces. Now, the three crystalline allotropes of carbon are diamond, graphite and fullerene, which you have to study in details. So let us move towards the first crystalline allotrope of carbon, that is diamond. The word itself attracts the people towards it. They are found in India, in our country, mainly in the Golconda region of Karnataka and Panna in Madhya Pradesh. Apart from our country, they are also found in different countries like South Africa, Brazil, America, etc. Let us study about its structure. Now, in diamond, if you see, every carbon atom is bonded to 4 neighboring carbon atoms by covalent bonds, due to which a three-dimensional structure is formed, which makes diamond very hard in nature, and hence the first property of diamond is brilliant and pure. Diamond is not only hard, but it is the hardest natural substance, having a density of about 3.5 grams per centimeter cube, melting point 3500 degrees Celsius, and when diamond is heated at a temperature of about 800 degrees Celsius in aerobic conditions, that is presence of oxygen, then carbon dioxide is the only product which is formed. Now here you might wonder, why carbon dioxide? See, when diamond is heated, what does diamond contain? It contains carbon as the main non-metal element in it. And when it is heated in the presence of oxygen, so when this carbon from diamond will combine with oxygen from the air, then only and only carbon dioxide will be the product which is given away. It does not dissolve in any of the solvents, neither acids or bases have any effect on it, and hence you can say that diamond is used in making ornaments. The last property is it is a bad conductor of electricity because no free electrons are present in diamond. You know, for any substance to be a good conductor, free electrons should be present, which are the charge carriers, and they lack this free electrons, which makes diamond a bad conductor of electricity. About its uses, we have seen it is used in glass cutting and rock drilling machines because it is the hardest substance. Used in ornaments, diamond knives are used in eye surgery, diamond dust is used for polishing other diamonds, and it is used to make windows, giving protection from radiation in space and in artificial satellites. Each and every use in details I have explained to you when the explanation of the chapter was done, when it was finished. Now here I would like to just inform you that whether it may be diamond, graphite, fullerene, methane, everywhere you have to study any 3 properties and any 3 uses, because the maximum weightage for such type of questions is 3 marks. I cannot ask uses or properties for 5 marks. So everywhere you can see 5, 7 properties uses are given. Select the 3 or 4 ones which you feel easy and study them properly. After completing about the first crystalline allotrope, that is diamond, we move towards the next allotrope of carbon, that is graphite. Looking at it, you come to know that it has a very black color. It is found in the natural state in different countries. This graphite is found in the natural state, natural form in countries like New Zealand, America, Russia, and also our nation, India. The main use is the lead, which is used in pencil. It is made by mixing graphite with clay. Every carbon atom in graphite is bonded to 3 other carbon atoms in such a way that a hexagonal layered structure is formed. Look at the varying characteristics of structure in diamond and graphite. In diamond, every carbon atom is bonded to 4 neighboring atoms, and here every carbon atom is bonded to 3 other carbon atoms. So this is the point which you can get under a distinguish between. A graphite crystal is made up of many sheets or layer of carbon atoms. Here you can see like the layers which you find in an onion. These layers, they slip over each other on applying pressure, and each layer, one layer of graphite is called as graphene. After completing the structure, let us see what are the properties of graphite. If you look at the graphite, you can see it is black in color, and about its nature, it is soft, brittle and slippery. Inside each layer of graphite, free electrons move continuously within the entire layer, and hence graphite is a good conductor of electricity. Now, we have seen that diamond is a bad conductor of electricity, whereas graphite, it has a large number of free electrons within each layer, and so it is a good conductor of electricity. See, here itself you have got 3 difference in the points. One is about their structure, that one carbon atom is bonded to 4 neighboring carbon atoms, whereas in graphite it is bonded to 3 neighboring carbon atoms. Second, diamond is, you can say, hardest natural substance, whereas graphite is not. It is soft, brittle, slippery. Then diamond is a bad conductor of electricity. Graphite is a good conductor of electricity. Next property is you know that graphite is used in lead in pencils. Hence it can be used for writing on paper. Density of graphite is 1.9 to 2.3 grams per centimeter cube. Fourth distinguishing point, density of diamond is 3.5 gram per centimeter cube, whereas graphite does not dissolve in most of the solvents. So these are the properties of graphite. Out of the 5, you can study any 3 properties. About the uses, it is used for making lubricants, carbon electrodes, used in pencils which are used for writing, used in paints and polish, and used in this arc lamps which give very bright light. For fullerene, which is the third crystalline allotrope of carbon, I have told you, you have to study only its properties and uses for the exam. Now, it is an allotrope of carbon which is very rarely found in nature, and the first example of fullerene is Buckminster fullerene C60. Now, this allotrope of carbon is named fullerene. Why it is being allotted this name? It is being given this name after the architect Richard Buckminster Fuller, because the structure of the C60, it resembles the structure of geodesic dome which he had designed. Other examples of fullerene are C60, C70, C76, C82, C86. These are the different, you can say, examples. Now, here you can see this appears in the spherical form. So, when the fullerenes are seen in the spherical form, they are called as buckyballs, whereas when you find them in the form of cylinders, they are called as buckytubes. So they are available in the form of buckyballs and buckytubes. So the first property of fullerene is molecules of fullerenes are found in the form of buckyballs and buckytubes. Second property, there are 30 to 900 carbon atoms in one molecule of fullerene. Fullerenes are soluble in organic solvents such as carbon disulfide, chlorobenzene, etc. 3 properties only are there. All the 3 you have to study. About its uses, they are used as insulators. They are used as a catalyst in water purification. The meanings I have told you during the explanation. Insulators, they are the substances which do not allow the current to flow through them, and catalyst is the helpers which help to carry out the reaction at a very faster rate. At a certain temperature, fullerene exhibits superconductivity. What do you mean by superconductivity? It is the ability of certain metals to allow the electricity to pass through them without any resistance at very low temperatures. That is superconductivity. So here we complete with the revision for the crystalline forms of carbon. Now we move towards the non-crystalline or the amorphous forms. I have told you its properties are not given in the textbook. Whatever properties you have studied for the crystalline forms, exactly opposite you are going to write for the non-crystalline forms. So for the non-crystalline forms, the very first property is that the arrangement of carbon atoms is not regular. Coal, coke and charcoal, they are the non-crystalline forms of carbon. Which were the crystalline forms? Diamond, graphite, fullerene, coal, charcoal and coke are the non-crystalline or the amorphous forms. Now you all know that coal is a fossil fuel. What does it contain? It contains carbon, hydrogen, oxygen. Also it contains nitrogen, phosphorus, sulfur. This coal, it occurs in the solid state and is of four types: peat, lignite, bituminous coal and anthracite. Now this formation of coal took place in different stages, in different steps. So each type of coal is a step in its formation. So the first is peat. Formation of peat is the first step in the formation of coal. When you take admission in the school, until you reach the higher secondary, you have to travel through different steps. That is the pre-primary, then the primary, then the secondary and the higher secondary. So similarly, when this coal was formed, it was formed in different steps, and here peat is the first step, which has 60% of carbon, high proportion of water and less percentage of carbon. So when you burn it, not much amount of heat can be obtained from this peat. The next step in the formation of carbon is lignite. This peat was transformed into lignite due to increased pressure and temperature inside the earth. It contains about 60 to 70% of carbon. The third step is bituminous coal. It was formed as the third step and contains about 70 to 90% of carbon. See, in each step as you move ahead, the percentage of carbon is increasing. As you move from the pre-primary to the primary section, then your knowledge increases. Your study level, it increases. Similarly here, as you move from the first to the next step, the proportion of carbon is increasing. And when you come to the last, that is the fourth step, anthracite, it is known as the pure form of coal because it contains about 95% of carbon, purest form of coal. So these are the different steps in the formation of coal: peat, lignite, bituminous coal and anthracite. You have to remember, I can ask as an MCQ. Dash is the third step in the formation of coal and the options will be provided to you. You have to select the correct option. The next is charcoal. You know charcoal, that is made from the animals. It is made from the bones of the animals, their horns, etc. and which is made from the plants. It is formed by the burning of wood in an insufficient supply of air. You can see the photograph. Then the different uses of coal. When you look at the word coal, its main use is it is used as a fuel because when burnt it produces a large amount of heat. So used as a fuel in factories and homes, used to obtain coke, coal gas and coal tar, and used in the thermal power plants for the generation of electricity. You know, in the thermal means where heat is required. So when this coal is burnt in thermal power plants, from that you get the electrical energy. So these are the different uses of coal. The next is coke. The pure coal that remains when coal gas has been taken away from coal, that is called as coke. What are the different uses of coke? It is used as a domestic fuel, reducing agent and the production of different gases like water gas, producer gas, etc. With this, we complete with the revision of crystalline and non-crystalline forms of carbon. I have told you for each and everything, whether it is coal, whether it is coke, whether it is fullerene, you have to study 3 properties and 3 uses each. Our next topic is very important from the 10th standard syllabus point of view. Hydrocarbons, which are known as the basic organic compounds. In the very beginning, I have told you that compounds which are directly or indirectly obtained from the plants and animals, they are called as organic compounds. And here, along with carbon, the element hydrogen is also included in most of the organic compounds. So the compounds which are formed from only carbon and hydrogen are called as basic organic compounds. So hydro and carbon, they are also called as hydrocarbons. You all have seen in the beginning that the atomic number of carbon is 6. Electronic configuration is 2, 4. We have seen in the very beginning of the chapter. So the valency is 4 because 4 electrons are there in the outermost shell. So either it has to donate this 4 to become stable with 2 electrons, that is the state of helium, or it has to accept 4 electrons and become stable with a state of 2, 8, which is the electronic configuration of neon. But instead, carbon neither donates nor accepts electrons. It shares its electron with other atoms of carbon or any other element. Means what? A carbon atom can form 4 covalent bonds with other carbon atoms or atoms of different elements, and hence covalent bonds are formed in such a case. So when a carbon atom shares 1 electron each with 4 hydrogen atoms, 4 CH bonds are formed, and this is known as methane, having molecular formula CH4, which is the smallest hydrocarbon. Now quickly we are going to see the properties of covalent compounds. The first is they have low melting points and boiling points. They are insoluble in water and soluble in organic solvents and are poor conductors of heat and electricity. All the 3 points should be memorized by you. Our next topic in short is saturated and unsaturated hydrocarbons. We have seen what is a hydrocarbon. Now, this carbon atom, its main property is it can form a chain of carbon atoms by forming covalent bonds with other carbon atoms. So hydrocarbons which have only single bonds between the carbon atoms, they are called as saturated hydrocarbons, and hydrocarbons having a multiple bond between 2 carbon atoms is called as unsaturated hydrocarbons. Now here the multiple bond, it can be a double bond or it can be a triple bond. Just now you have seen methane. Just we will go back to its structure. You have seen here methane. Carbon is having single bond. There is no double or triple bond. Then it is a saturated hydrocarbon. If there is a double or triple bond, then we say it is an unsaturated hydrocarbon. Now let us move towards the next topic. You have to study about carbon dioxide in details. Today we will see what its molecular formula is, what is its molecular mass, where does it occur, and then we will study its physical and chemical properties. Carbon dioxide, you well know from the lower standards, it has molecular formula CO2, molecular mass is 44 and its melting point is minus 56.6 degrees Celsius. It occurs in the air in the free state to the extent of about 0.03%. Now to verify the physical and chemical properties of carbon dioxide, a small activity I had told you that you have to mix calcium carbonate, that is CaCO3, with HCl. Means you have to take CaCO3, calcium carbonate, in a round bottom flask, and in that you have to add dilute HCl, and you have to see that the whatever HCl you are adding, it should reach the calcium carbonate and reaction should take place, and in this calcium carbonate and HCl reaction, carbon dioxide is formed, which has different properties, and how the properties are verified, how they are tested. The first is to check the smell and see its color. So when it was tested, it was found that the gas has no color and no smell. About the chemical properties of carbon dioxide, when a burning candle was immersed in the gas jar which was containing carbon dioxide, the flame of the burning candle was put off, means carbon dioxide does not support combustion. About its reaction with universal indicator, it was found that the color of the universal indicator turns to yellow or orange. When lime water was allowed to pass through the gas jar containing carbon dioxide, it turns milky. When tested with water, it was found that it sparingly, very rarely dissolves in H2O, forming H2CO3, that is carbonic acid. And when blue and red moist litmus papers were immersed in the gas jars containing carbon dioxide, moist blue litmus, it turned red, whereas the red litmus paper, it remained unchanged. So these are the different physical and chemical properties of carbon dioxide. I have told you last time, if you see textual exercise question number 9, how will you verify the properties of carbon dioxide? Here in the textbook on page number 145, the different points are there. Observe the color of the gas, smell the color of the gas, which I have given you in writing. Don't write anything in the notebook. Only and only the chart which is given on that page, this chart. You have to copy the chart along with the observations, that is the readings. So for the exam also you are going to prepare in the same way. Next is the uses of carbon dioxide. You all know it is used to make aerated drinks. Solid carbon dioxide is used in cold storage and also to keep milk and milk products and frozen substances cool during transport. It is also used to get special effects of a mist in dramas and movies. Next is, we had studied about fire extinguisher in details. So carbon dioxide, which is obtained by the chemical reaction, it is used to extinguish fire in fire extinguishers. Liquefied carbon dioxide is used to remove caffeine from coffee. Liquid carbon dioxide is used as a solvent in modern eco-friendly dry cleaning. And all of you know that plants, they use the carbon dioxide from the air, leaves of the plants, and by trapping the sunlight, they utilize this carbon dioxide for the preparation of food. And this process is called as photosynthesis. So carbon dioxide is used by the green plants in the process of photosynthesis. So today we have revised about the general occurrence and introduction of carbon. Then we have studied about its crystalline and non-crystalline forms in details. We have seen what we mean by hydrocarbons and what are saturated and unsaturated hydrocarbons. Then we have studied about the physical and chemical properties and the uses of carbon dioxide. We will wind up with our today's session, and in our next session we will continue with the revision of this chapter, because this chapter is quite lengthy. If the entire chapter I revise in one session, then it will go above your heads. So half of the remaining part, that is the detailed study of fire extinguisher, how carbon dioxide is used over there. Then the detailed study of methane, about its occurrence, physical, chemical properties, uses, and the biogas plant. We are going to take up in our next session on Monday. And along with that revision, after the completion of that revision, we will start with a new chapter from section B, that is life processes in living organisms. Hence, I will request all of you, before you attend the next session, at least go through the first 2-3 pages of chapter number 15. Thank you, dear children.